Hello everyone, I am Shubputra Pancha, Assistant Professor, Department of Computer Science and Engineering, BADSVP Dr. PG Halkatti College of Engineering and Technology, Vijaypur. In the last class, I have discussed about one-time pad and along with one simple example and the summary of that one-time pad. So that what I discussed is it is probably secure. So based on that one-time pad, there are some real-world examples happened with the reference of that one-time pad. So again, we'll be discussing. We'll go for this module level outcomes. Now, still we are in module level outcome two, that is study and analyze cryptography additional traditional methods. So here in the last class we discussed one-time pad. So how exactly it works with some examples and all. So now in the real world, how one-time pad is used. So there is a project called as Venona. So it is executed in the US. So what happens is there is a spice called as Soviet spice encrypted messages from US to Moscow. I mean, their government sent some spies uh, for encrypting, for sending some data from US to Moscow. So, how actually they sent the data by encrypting such data by using one-time pad, and such spies sent with different one-time pad keys. So, what they did is it happened in 30s, 40s, and 50s. So with a name called as nuclear espionage, etc. Thousands of messages needs to be transferred from US to Moscow. In that case, what spy does is spy carried one-time pad into US. So different one-time pad, different keys into US. Once with that, what spy does is spy used a pad, that is keys, to encrypt all secret messages with different one-time pad and repeats within the one-time pad made cryptanalysis possible. So here with that, what spice does is they have sent the information from US to Moscow after encrypting the data to Moscow. This is how we can say that uh, the one-time pad is probably secure. So this is what Venona decrypt, that is in 1944. This is the message here, and this particular information needs to be transferred. So here some of the information messages here, Ruth green glass, that these are some one-time pads, that how it is going to be decrypted. Liberal, so there the name is Julius Rosenberg. Then enormous, the atomic bomb, like that the messages are going to be encrypted. So this is how one-time pad is used for the project Venona. That is just an real world example happened in the year 30, 40s, and 50s. So now the next concept is codebook cipher. So what is exactly this codebook cipher? So this codebook cipher will also be used in the earlier days. So that is in 1950 or 60, like that. So how exactly this codebook cipher works is, suppose if any person wants to encrypt the data, so that data to be encrypted in the form of codebook. There is some codebook. It comes with only codes. So one particular code for one word, one word. So that word can be referred with a particular code from the codebook cipher. So how exactly? Literally a book. It is nothing but a book filled with code words. That is only numbers. And each unique number is replaced with one word. That is a plain text word or English word. So if a particular person wants to encrypt the data, that sender or person, what I can say, has to refer that code book, that particular book, to encrypt the data. So we can call that as a Zimmerman telegram. So that is what something else. Suppose, for example, one person wants to send a data, so that data is to be sent in the form of Zimmerman telegram, that is to be encrypted via code book. So here there is some examples here. There are some words along with its code words. Say something else. It is February 13605. Fest is coded with 13732. So all these code words will be available in the code book. So like that similar example, you can see that. So modern block ciphers are code books. This is what we can say. Now more about this later. We'll discuss more about this code book later. Before that, we'll go for one more information. So code book cipher we can also call it as the additive. How exactly the data is going to be encrypted using code book cipher. So initially all the words will be replaced with the code words referring the code books. Code books also usually use additive. Along with that unique words, some additive information should also be added with the code words. So additive in the sense book of random numbers. Encrypt messages with code book. Then choose position in additive book. Add in additives to get ciphertext. Send ciphertext and additive position. Additive is nothing but it's a simple position. Along with ciphertext, the additive position will also be sent to the receiver. Recipient subtracts those additives before decrypting. So why use an additive sequence? What is the use of this additive sequence? So that additive sequence is only for the purpose of how, so in which order receiver has to decrypt the plain text using the code book. So this is what that image of that Zimmerman telegram, perhaps most famous code book ciphertext ever. So here this particular code book has sent by some sender to the receiver. It comes with only the code numbers, and that is to be sent to the receiver. Receiver has to use the additive information in which order receiver has to decrypt these code words and to get plain text. You can see that receiver something as Zimmerman telegram decrypted. British had recovered partial code book, then able to fill in missing parts. So now you can see here we intend to begin so that all those code books code numbers are replaced with the plain text. So how exactly this particular sentence of plain text got is into that is because of that additive number. So that receiver has to maintain the order. Now the next concept is random historical items. So here in this crypto timeline, these are just example how exactly the transformation cipher works. Pattern Kettle uses the transformation cipher, then Caesar cipher, um, post short story that is happened in 1843, the gold bug code breaker. Then one more example is election of 1876. So these are something else. Some events happened during such duration, right? So for such duration, for such events, which are all cryptographic techniques applied for encrypting the data. And one good example in that is how that election of 1876 was conducted. So that is what the example of election of 1876. So this I will discuss it in the next class. Thank you.